All right, hello once again. This is Jeff Scott of Blackhawk Technical College. I've been going over the book material for the 152-143 Intro to Java Programming class for the Spring 2016 semester. We've been going through the Gaddis book, starting out with objects. I think they're starting out with Java through objects or whatever it is, 6th edition. I've gone through the first 11 chapters as far as the PowerPoints, and I've gone through the book, chapters 1, 2, and 3, including I've written about 4 programs thus far. At the end of this chapter, I'm going to write 2 more programs. Basically, it'll be the same program, but one will handle input validation and just do it the way we've been doing, writing things, and the second one will not only include input validation, but it will also write to a file. All right, so if we see here our topics: increment and decrement operators, while loop, do while loop, and for loop. Then we get into running totals, talk about nesting loops, break and continue, deciding which loop to use. Then there's an intro to file I/O. And the chapter ends with generating a random number class and common errors. So the first is the plus plus and minus minus, and those are known as the auto increment and auto decrement operators. I may have shown something like this before, but I'm going to show it again anyway. If I say int x equal 3, int y equals 0, then if I say y equals plus plus x, what that means is add 1, let's do it like this, add 1 to x, assign to y. So when done, x equal 4 and y equal 4. So in other words, we're doing the increment first. So add 1 to x, which will make x 4, and then assign x to y. So they'll both have a value of 4. So let's look at that example again, but this time let's say x plus plus. In fact, let's just put the x here. All right. Now it says assign x to y, add 1 to y, to x rather. When done, x is going to be equal to 4, but y is going to be equal to 3. So I'll leave that up there for a second. Again, this is the auto increment operator. Sorry. All right. Sorry about that. But again, this is the auto increment operator. So you see 2 different instances of it. All right, let's reverse this. So let's do the auto decrement operator. Again, this auto increment and auto decrement can only be used to add or subtract 1 from a value. So the first one says you subtract 1 from x and assign it to y. So when you're done, x is going to be 2 and y is going to be 2. In the next example, you assign x to y and then you subtract 1 from x. So again, x will be 2, but y will be 3. All right? And again, I'll leave those up there for just a second. They're oftentimes used with loops when you want to increment a loop by 1 or decrement a loop by 1 inside the body, especially of a for loop. So you can read your own stuff in here on this. Maybe what I did was better, maybe what I did was worse. But when you put the plus plus first, it's called pre-increment. If you have it after the variable, it's post-increment, or pre-decrement, post-decrement, if you're using minuses. So the difference is what I just showed you. All right, let's write quickly code 3 different Java programs that will, and I may have done this before, I don't remember if I did this when I went over the PowerPoints or not, but I'm going to do it right now, and that is I'm going to write 3 little programs, and both of them are going to print out the numbers from 1 to 10. So int x equal 1, while x less than or equal to 10, system.out.println x equals plus x, x plus plus, and it wouldn't matter here if I said x plus plus or plus plus x, it would have worked the same way. So this is a while loop. It's called a pretest loop. If for some reason we had said this, all right, so x is 1, but if we had said if x is greater than or equal to 10, and here it's not, so we would have totally skipped the loop and we would have gone down to here. But by saying it's less than or equal to 10, this should, if we wrote it correctly, should print out x equal 1, and it should print that out 10 times with the numbers from 1 to 10. 3, 4, 5, 6, 7, 8, 9, 10. All right. Stretch this up a little bit so we can see all of it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now, every loop has got to have 3 different ingredients in it. Here's the first one, and it's called increment the loop control variable. Let me move that over a little bit. Increment the loop control variable. That's the first thing. Second, we have to test the value of the loop control variable. And third, we have to change the value of the loop control variable. And I think I probably did go through this already, but all right, quite often when I write these, I literally, for my loop, the name of my loop control variable, I literally use the name LCV, loop control variable. So let's look at this again. I'm creating my loop control variable and I'm initializing it. So I'm both declaring it, which is right here, and initializing it, which is right here. So I'm initializing my loop control variable to 1. Then I'm saying as long as that loop control variable is less than or equal to 10, and since it's 1 to begin with, we will go into the loop body and we'll say LCV equals 1. Then we'll add 1 to it, making LCV 2. And it'll say, is LCV still less than or equal to 2? Yes, it is. So it'll come through and it'll say LCV equal 2. And it will do this 10 times, as is shown right there. After it does it the 10th time and it prints out LCV equal 10, it'll add 1 to it, which will make LCV 11. It'll come up here to check it, and it'll say, is it less than or equal to 10? No. So it'll pop out. So that's a while loop. All right, that's the first one. And as I mentioned, it's known as a pretest loop. All right, let's copy all of this code here. We'll paste it in, make a couple fairly minor changes, but I'm going to grab this code right here, and I'm going to just type in the word do right there, and down here I'm going to put in this. All right, so this is called a do-while loop, where previously with a while loop it was a pretest loop. This is called a post-test loop. You always go through the loop only, at least 1 time. So even if you'd said there, if it's less than or equal to -10, which this is not less than or equal to -10, but since you don't check it till the bottom of the loop, you would have printed out LCV equals 1 there anyway. So let's play computer again. So the loop control variable is 1. So we'll print out that it equals 1, and we'll add 1 to it. All right. So we're going to check. is 2 less than or equal to 10? Yes, it is. So it'll keep going through this, and when it does it the 10th time, it'll add 1 to it, making it 11. And is 11 less than or equal to 10? No, it's not, so it'll fall out of the loop. Again, this is called a post-test loop because you always go through it at least once. This is also the only looping structure where you actually do put the semicolon at the end. So if you look, there's the while loop where the test is at the beginning. And there's the do while loop, which looks very similar except the test is at the end. All right, let's grab this one more time. And let's paste it in one more time. And I'm going to make some changes again. All right, I'm going to say int LCV right here, but I'm not going to give it a value. I'm just going to say, yeah, I can give it a value, that's fine. All right, but this time I'm going to use a for loop. And I'm going to say for semicolon LCV less than or equal to 10 LCV plus plus. All right, I don't need this at the end, so that's gone, and I don't need this line here either. And looky here. All right, I can get rid of the comment. In fact, if I want to, I can even declare this loop control variable that we have right there. I can put that right in here. So I can do that. So it's very concise. In one line of code, I have created and initialized my loop control variable. I am testing my loop control variable, and I'm incrementing my loop control variable, all in the same line. So again, this will also print out LCV equals 1 through 10. Those are the 3 looping constructs that you have. So the author goes through here in a lot of coverage and says while, and when you use a while, that's got to be a Boolean expression in there, so it's got to be true or false. All right, he's got an example with a while loop where he prints out hello 5 times, all right, where I just printed out the numbers from 1 to 10, and then he explains what's going on in here. So again, he says we have to test, we have to change. Same stuff I told you. He talks about it being a pretest loop, and I just told you about that. If you never change the value, if you never change the value of your loop, so in other words, we'll grab the while loop. We'll grab that example, which was the first one here. If for some reason I leave this line out, now it's going to print LCV equals 1, LCV equals 1, LCV equals 1, LCV equals 1, and it's in an infinite loop. You must change the value of the loop control variable. Also in this case, if I, instead of saying plus plus, if I said minus minus here, that would also be an error. Because it would say LCV equals 1, LCV equals 0, LCV equals -1, LCV equals -2. We're getting farther away from 10, not closer to 10. So you have to make sure that unless you want an infinite loop, and there is a certain amount of software that runs with an infinite loop, but unless you want an infinite loop, you must declare and initialize your loop control variable, and that shouldn't have said increment right there. That should have been initialize. Because that's what we're doing, is we're initializing the loop control variable right there. All right, we're testing it and we're changing it. We're again initializing it here. We're testing it and we're changing it. Here we do all 3 in one swoop. So again, right here, this is the init LCV, this is the test LCV, and this is the increment LCV. It's being done here, here, and here. All right, hopefully that made some sense to you. All right, I like to go through it like this as opposed to the way that the author does it. Again, if you only have one line of code, you do not have to put it in curly braces. If you have more than one, you do. I always put it in there anyway. Again, he's got a program with a while loop in here. It's fairly well done. Thing on temperatures. he mentions talking about using a while loop for input validation. So for instance, notice in here we tell the user to enter a number between 1 and 100, and then we attempt to parse it. If the number after parsing is negative or it's greater than 100, we give them an error message and we ask them to do it again. We are starting to go through the process of what is known as input validation. We're making sure that our input is what we asked it to be. We're going to do the same thing in the payroll program in just a few minutes. Then he goes through the do while loop, says the same stuff that I've said. Again, this is the only kind of control structure that must be terminated with a semicolon. And he shows you how you do a while loop as opposed to doing the same thing with a do while loop. It's virtually identical to what I just showed you. Again, he's showing you a little bit different example, but the ideas are the same. Then he goes through the for loop, and again, the for loop is a counting loop, and as I mentioned, it does all three things on one line. You don't have to do all three things on one line. All right, but typically that's the way that it's written: for initialization, test, and update. All right, and there's an example where he goes through it here on 208 in a lot of depth and breadth of coverage, but very similar to what I mentioned to you in the example that I gave you. You should never change your loop control variable within the loop. You should never do that. It's just considered bad practice. If that's the case, you shouldn't be using a loop, or with a for loop, I should say. All right, we're already doing an X++ here. Why would we want to do it again here? So you might say, okay, Jeff, got you here. I got you, but let's talk about this. What if I'm doing this, just like you said, and what if I want to come in here and I want to add, I want just the even numbers. So I want to print out 1, 3, 5, 7, and 9. Well, you still don't do it like this. That still isn't right. Then you say, instead of X plus set plus, you say X plus equal 2. Then it'll print out X equal 1, 1, 3, 5, 7, and 9. Okay? When you were writing a for loop like this, none of these are mandatory if you've set them up previously. In fact, if you want an infinite loop, if you want a loop purposely that runs forever, using a for loop, you can say for semicolon semicolon. That will be an infinite loop because there's no test, there's no increment or decrement. All right, again, I'm trying to just go through the highlights of what's in the chapter here. I've already gone through the PowerPoints. Here's another one, another good program. Kilomiles and miles per hour that he goes through with a counter control loop. All right. Yeah, I'll let you look at that on your own, and he gives you some examples. All right, running totals and Sentinel values. All right, a running total is a sum of numbers that accumulates with each iteration of a loop. Again, I showed an example similar to this before, but I'm going to show it again. And that is this. What if I want to do this? What if I want to add 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus all the way equal to plus 100? Okay? Do you understand? I want to literally add all those numbers from 1 through 100. Well, an easy way to do this is I can come through here and I can use any of the loops. We can use any of them. So let's use a for loop. So I'm going to add another variable here that I'm going to call sum, and I'm going to set that equal to 0. Now I'm going to say for LCV equals 1, LCV less than or equal to 100, LCV plus plus. Sum plus equals LCV. That's it. Now I don't know what that number is, but this code that you see right here is going to do exactly what we want it to do up here. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10, all the way through plus 99 plus 100. All right, so whatever that number is. And what's nice is I can put it into a loop. What is it, 4 or 5 lines of code, all right, including 2 lines that are just curlies, and write it. And if I wanted to know the numbers from 1 to 1,000,000, all I have to do is change that number I have in there where I say LCV less than or equal to 100. I just have to change it to 1,000,000. And boom, I'd have the addition of all numbers between 1 and 1,000,000. All right. Okay, that's a total or an accumulator, a running total. Then let's look at the other one, which is a Sentinel. All right. A Sentinel value is a special value that would never be mistaken for an actual valid value. So here we're saying enter the number of points your team earned for each game this season. When you're done, enter -1. So -1 is the Sentinel value. You couldn't score a negative number of points in a game. The least number of points you could score would be 0. So another way to write this would be to do something like this. And again, I'm not going to put all of it in here, but let me just grab a little bit of it here. And I'll tell you what, maybe I'll throw it into here. All right. So I have to get rid of all these, of course. And I'm not trying to waste my time, I'm not trying to waste your time, but where you might use something like this would be, what if I asked, instead of all the stuff that's being shown here, what if we asked you to enter a test grade? All right, so we set something in here. Enter the test grade. We let them know it was between 0 and 100, or -99 to end. Then in that case, the Sentinel value would be -99. So it's a number that would never be considered a valid input. That's what you use as a Sentinel value, to show that you're done with inputs. All right, neat program here. All right, nested loops. Okay, and I want to grab the whole doggone thing here. Fortunately, I get the line numbers along with it, but that's okay. We're going to just roll with it. And what do we have here? This program, and it's so cool because of both its complexity and how short it actually is, which sounds like contradictory terms, but that's okay. As they mentioned, this program is going to simulate a clock. Like I said, to me, that's what's so cool about the program. So I'm going to move this up quite a ways here. So what we have here are 3 for loops. We have a for loop within a for loop within a for loop. Nested loops, which is totally legitimate. There's your whole program that creates a clock. Now think about this. This is going to go through all the numbers that are between 1 and 12. Well, let's change it. Let's make it everything between 0 and 23. Now we've got a total military clock. So as we run this, it will start with 00:00:00, and it'll give us every time through 23:59:59. So in other words, it's simulating an entire day right now. There are 60 seconds in a minute, 60 minutes in an hour, and 24 hours in a day. 60 times 60 times 24, I believe, is like 84,600 or something like that. So literally, that's going to print out all of the values. Now, though, in the example in the book, what they did was they started at 1 o'clock and they ended at 12, or at 1 o'clock, 1 o'clock to 1 o'clock. But you get the idea, it'll run. And I've written this program before countless times. I like it so much because, again, as it says, it's a simulated clock. You've got an inner loop that goes through everything for each minute, then another inner loop that goes through each minute of each hour, then an outer loop that goes through each hour. All right? Here's the thing with test averages. Again, when you've got nested loops, you have a loop within a loop. You can have a for loop within a for loop, a while within a while, a do while within a do while, or mix and match them any way you want. A for within a do, a while within a for, etc. And there's no limit to which you can do this. So he's got another example in here where he draws some rectangular patterns. Looks very Christmassy, and we're right before Christmas. So, all right, let's look at the break and the continue. All right, and let's go back to the examples that we had before. I'm just going to go to the while loop. Okay, so we're doing all this stuff where we're printing this out, and then we're adding 1 to it. All right, so let's say we come through here, and I'm going to say here, if LCV equal 6, I'm just going to say this, break. All right, so now what it's going to do is it's going to print out LCV equals 1, LCV equals 2, LCV equals 3, LCV equals 4, LCV equals 5, LCV equals, after 5, it's going to add 1 to it, and we're going to say, does it equal 6? And now it does. So it's going to take all the rest of the lines that are in here, and it's going to remove them. So break breaks you out of the loop. All right? Typically, that's considered bad practice. You're in a loop because you want to go through it a certain number of times. Now, if I change it from loop to continue, or from break to continue, now if it equals 6, continue. So now it'll look like this. It'll skip 6. All right? And actually, what I should have done here is I should have taken that line right there and put it down here. Okay? For either the break or the continue. All right, in both those cases. So if this was break, this would have 1 through 5, and with a continue, it has 1 through 10, but it skips 6. If you don't like my examples, I'm sure Gaddis did much better in the book. All right, he talks about when to use which loop. Again, when you talk about this stuff, it very much is a crapshoot in that a lot of programmers I know will use a for loop whenever they can because it results in less code. Most people don't like the do while loop because it's a post test. But if you want to make sure, for instance, maybe you're checking error code and you want to make sure that it runs at least once, so it might make sense to use a do while. Most programmers, though, tend to use for loops the most when possible, then while, then do while. All right, the last part of the chapter, starting on page 230, is going to go over file input and output. As mentioned, the Java API provides several classes that you can use to work with files. Well, we know this then. What that means is we can go over to java.sun.com, as we've done several times, find the Java APIs, choose API or Java SE8, and come down here and start looking for stuff that starts with file. And there's file itself. So there's a class file, and you'll notice it's a big class, so there's a lot of stuff you can do with files. Files are made for persistent data. In other words, with all the programs we've done thus far, every time we've done a program, when we stop the run and then run it again, whatever was there previously is gone. If we want to save it, if we want persistent storage, we need a file or a database. But we're talking about files now. So when you work with files, as mentioned here, there are generally 3 steps you need to work with for files. You got to open the file, write data to a file or read it from a file, and then when you're done, close it. All right? So as it says, if we want to write data to a file, we use what's called the PrintWriter class. So we do something like this. PrintWriter output file equals new PrintWriter student data.txt. That's going to create a brand new, spanking new file called student data.txt. If the file previously existed, it'll be overridden. Okay? So here we're telling you to enter a file name, and we're assigning it to a variable called file name, and then we're setting it up that way. Again, if you are opening a file with PrintWriter that already exists, it is erased and recreated, or whatever you add, becomes the new file. As mentioned, you should always, when you're done, close the file, and notice what we do here. Instead of system.out.println, which remember system.out is by default, it is our screen. Now we're saying the name of the output file.println to write it out. So we're going to do stuff like this. So it's going to, as it mentions on the bottom here, it'll write Jim, then have a carriage return, 95 carriage return, Karen carriage return, 98 carriage return, Bob carriage return, 82 carriage return, and that's it. So it'll look like this. The PrintWriter class also has a print method. As it says, it's used to write an item of data to a file without writing the new line. So instead of print line, it's print, just like system.out.print has print line and it has print. Same kind of way. So here we're grabbing a bunch of information for a person, and we're using print, print, and print line. So when we put them in there, it's going to look like this. Okay? Again, very soon I'm going to go through an example with you where we're going to rebuild that payroll program, but we're going to rebuild it once and use a while loop and do some, or several while loops, or whatever it is. And we're going to do some input validation, and then we'll keep all that code, but we'll add the ability that we're able to take our stuff and save it to a file. All right, when you're working with files, you've got to be wary of the fact that you can have exceptions. You might try to write to a folder or whatever that either doesn't exist or is read-only or whatever, or you don't have permission for whatever reason, or it's filled, whatever it happens to be. So what this is doing is it's letting Java know, the compiler know, that it's possible that main in this case could throw an I/O or an input-output exception. It does not say that it will. It's saying that it possibly could throw an I/O exception. So if everything works okay, it just basically skips it. All right, page 235, the author says, before moving on, let's review the basic steps necessary when writing a program that writes data to a file. You must import java.io.star at the top of your program. All right, since we haven't talked about exceptions, we don't until like chapter 11, any method that uses a print writer must have a throws IO exception in its header. All right, and you create a print writer object and pass the name of the file as a string to the constructor. Now, if you don't want to remove the data that was there, then rather than, this looks just like what we had before, except we put true on the end. So that means rather than open up the file in write mode, you open it up in what's called append mode. So you put the file pointer at the end of the file, and you don't remove the stuff that was there previously, you just add to it. All right. When you're working with files, this can get really ugly if you have to do this, because with Windows it uses backslashes, so you have to use //. Luckily, all right, I believe you can do this. It says on a Unix or Linux computer. think Java lets you substitute forward slashes, so you can do this. You don't have to do this. All right. Well, writing data from or to a file is only half the battle. You have to be able to read data from a file. So the author uses our old friend scanner that we had back in Chapter 2, but there's a lot of ways that it can be done. So reading lines from a file with a next line method. Well, we've done something like this before. But now instead of saying here keyboard.nextLine, it's inputFile.nextLine to write it to a file. Again, you're going to see an example somewhat similar to this in a few minutes. All right. It says here, quite often the program must read the contents of a file without knowing how many records or how much information is in it. So for example, with scanner, it has a hasNext. HasNext is known as a peek function, P-E-E-K, which means it does a look ahead type of thing. And if it finds what looks ahead, if it sees what's called an EOF marker or an end of file marker, it knows to stop and not go any further. So that's what they talk about in here. While it has next. If that fails, it's because it found the end of file marker. All right. If you want to see whether or not a file exists, there is a built-in method that's called file exists. Again, I already showed you in the API where the thing on files is, and we're going to look at an example. And I'm not saying files aren't important. Of course they're important. They're probably not as important, probably at least, not as important as database, working with a database in any programming language, because most of the time today, rather than just using text files, people write things out to databases. All right, last thing in the chapter, starting on 249, talks about random numbers. And you use random numbers in games, simulations, statistical programs, a lot of different, to encrypt data. So if you want to do any work with random numbers, you have to import java.util.random. That allows you to use the random class. So you say a random followed by any name you want to give it equals new random. And as it says, this statement does the following. It declares a variable named random numbers. The expression new random creates an instance of the random class, and the equal sign assigns the address of that random class to the random numbers variable. All right, and as you go through this, you quite often want to do something like this. Now, if I took that number right there, I'm going to grab that, I'm going to copy it, and I'm going to paste it out here in this mess that I've been using today. If I do this, and I'm going to change that from a 1 to a 100, this generates a random number between 1 and 100. And actually, any random number thing that's in here, actually what it does is it generates a random number that's between 0 and less than 1. So up to 999,999, whatever. So by saying what I want is the next int, this by default, this part right here, is going to give me a random number between 0 and 99. By adding the 1 to it, it will now give me a random number between 1 and 100, which in this case is what I'd want. There's also, there's a next double, a next float, etc. So there's several of these. They give you a math tutor problem where you can, put some stuff in there for adding and subtracting and stuff. It's kind of a neat little program. A dice program, for whatever reason, most of these people who write this stuff have got some kind of a fetish with dice and gambling and the like. Here's our common errors. Again, please read those. Feel free to ask if you have any questions on them, and we'll do a couple of the examples that are at the end of the chapter as a class. That's it. So I'm going to take this video and I'm going to produce it. Then I'm going to come back and rewrite the payroll program to include loops. So we'll do that momentarily.